All right, so this is day 2 of similar triangles. It was called similar polygons, so I guess it's more specific. But you're going to see some things that we did in the day 1 notes and then a little bit more added to that. So here's the warm-up, which is similar to what we've already seen. So you can go ahead and pause the video and try this one on your own. Okay, so hopefully you remember at least that when you have similar triangles, just solve for any missing values that are on the sides, like an X or a Y that are on the sides. You're going to use a proportion. So in order to set up your proportion correctly, you are going to have to use the similarity statement and mark the angles that are congruent so you can match up the proportionate sides. So I know J and H are congruent, so angle J is congruent to angle H. I and A, and then I'll use my third angle as my blank angle, L and Y. Okay, so I will come over to the triangle on my left, and I'm going to start by picking X plus 16. X plus 16, and now I have to match it up with its corresponding side. So if you look, X plus 16 is in between my 2 tick mark and no tick mark side. So 2 tick mark and no tick mark side is 8. Come back over here. I'll choose 15 because that's the only thing left to choose. It's in between my 2 tick mark and 1 tick mark. 2 tick mark and 1 tick mark is X plus 2. So you might be asking yourself, what about the 10? We don't use it for anything. So that was, once again, 15 from the triangle on the left over X plus 2. Now I can cross multiply and solve this. So X plus 16 is a binomial, and so is X plus 2, so I want to put them in parentheses. Then I have X plus 16 times X plus 2 is equal to 8 times 15, which is 120. Now remember, in order to solve this, I'm going to have to FOIL this first. So I'm going to multiply it out. X times X is X squared. X times 2 is 2X. 16 times X is 16X. And then 16 times 2 is 32 equals 120. I can combine like terms on the left side. And I have X squared plus 18X plus 32 equals 120. And I can't solve this yet because in order to solve it, a quadratic, I can't solve it by square rooting. I want to try factoring next, but in order to solve by factoring, it has to be equal to 0. So I'm going to subtract 120 from both sides. So now I have X squared plus 18X minus, that's 88 equals 0. All right, so now I can factor this. There is no GCF, so I'm going to make my organizational X. A times C is negative 88, and B is 18. So two numbers that multiply to give me 88 and add to give me 18. So you might not be very familiar with factors of 88, so start running through them. Is it 1 and 88? No, that's never going to give me 18. Is it 2 and 44? No, that's not going to happen. Does 3 even go into it? No. 4 does, 22 times. Ooh, 4 and 22 sounds good. 4, 22, but I would have to make the 4 negative. Divide by the lead coefficient, which is 1. So I have X minus 4 times X plus 22 equals 0. And then set each factor equal to 0 and solve. So you get two solutions. X equals 4 and X equals negative 22. So now I'm going to look because I got a negative answer and this is a side length. So I say to myself, if I plug in negative 22 right here, I'm going to get negative 20. That side length can't be negative 20. So X is just 4. Okay. Next, what we have is still a practice of what we did yesterday. This is not anything new. We're going to go through it to make sure you got it. So once again, I'm going to use my similarity statement to match up my congruent corresponding angles. Angle A is congruent to angle D. Also, since angle D is already labeled 101, I'm going to label angle A 101. Why not? Angle B is congruent to angle E. I'm going to label B 3Z plus 1 since E's labeled that. And then I'll use my blank angle C and F are congruent, but I can put a 15 right here because they're the same. All right, so now if you look, I can solve for my missing variable in my triangle, in my angles, because I have all 3 angles in the triangle. So I'm going to start by solving for Z. I'm going to do 3Z, ooh, not in that highlighter though, 3Z plus 1 plus 101 plus 15 equals 180, because all three angles have to add up to 180. So I have 3z plus 117 equals 180. Subtract 117 from both sides. 3, oops, I changed it to an x. I was going to say z out loud though, so 3z equals, that is 63, divide by 3, and I get z is equal to 6 divided by 3 is 2, 3 divided by 3 is 1. Z is 21. Okay, now I have to solve for x and y. So now I'm going to decide, do I have to solve for x first, y first, or it doesn't matter. So if you look, there's 2 x's here and here, okay, and only 1 y, so I'm going to solve for x first. Now remember, if it's sides, I'm going to use proportion to solve it. All right, so I'm going to start by picking a side that has x in it. I'll start by choosing this side and putting x plus 4 right here. And now I need to know what its corresponding side is. So if you look, x plus 4 is in between 2 and no tick marks. So I'm going to do 2 and no tick marks is 18. Then I'm going to use x plus 2. X plus 2 is in between 1 tick mark and no tick mark. 1 tick mark and no tick mark is 14. So that's x plus 2, 14. All right, so now I can solve for x by cross multiplying. So I'll multiply these two. 18 times x plus 2 is equal to 14 times x plus 4. Distribute, 18x plus 36 is equal to 14x plus 56. Okay, now I have to get all my x's on one side, so I'm going to subtract 14x from both sides. 4x plus 36 equals 56. Subtract 36 from both sides. 4x equals 20, divide by 4. X equals 5. So now I know x is 5, and I can box that as an answer. Now remember, you still need to solve for y, and we chose to solve for x first because we had to. We needed it to solve for y. So now I'm going to go replace all my x's with 5s. So this is 5 plus 2, so this is now 7. Okay. This is 5 plus 4, so this is now 9. And that's all where the x's are. Okay, now I have to solve for my last variable, which is y. I know I'm going to use a proportion. I know that I have to use this no matter what. So I'm going to say y plus 1, and that corresponds to the 10. I could always double check by saying it's in between 2 marks and 1, 2 and 1, so yeah. And then I can either pick the 9 or the 7 from this triangle here. It doesn't matter. I'm going to pick the smaller number because that means I have to work with smaller numbers. So I'm going to do 7 over, and then I picked the boxed side, so 14. But notice that's 7 over 14 is a half, and so is 9 over 18. So it would have given me the same answer when I'm done cross multiplying. 14 times y plus 1 is equal to 70. Distribute, 14y plus 14 equals 70. Subtract 14. 14y is equal to 56. Right? 70, 60, 56. Yes, divide by 14. And y is equal to 4. Okay, so I have ZXY. Was there anything else? There sure was, a scale factor. So I can plug y in if I want now that I have it. So I can plug in 4 here. 4 plus 1, this is now 5. That's 10. And now I can pick a ratio of any of corresponding sides. So I can do 5 over 10, or I can do 7 over 14, or I can do 9 over 18. Notice they all simplify to the same thing, the scale factor, which is 1/2. Okay. All right. So in chapter 4, we learned this is the new stuff added on, but it's not overcomplicated. So just pay attention, and I think it'll be an easy transition here. In chapter 4, we learned 4 ways to prove two triangles congruent. Do you remember them? Pause the video, see if you can list all 4 ways. If not, I'll give you a hint as to which one of them is. Side, side, side. Okay, good. So we have side, angle, side. angle, side, angle, and angle, angle, side. Today, we're going to learn a way to show triangles are similar, not congruent, similar. Recall the sign used for similarity, which is this right here, this tilde. Okay, so this is called the angle-angle similarity postulate, and we abbreviate it angle-angle similarity. It says if two angles of one triangle are congruent to two triangles of a similar triangle, or of another triangle, and the two triangles are similar. Okay, so if you look here, and obviously, like if you said that this was 30 and this was 60, this would have to be 90. So if this is 30, this is 60, this is 90. So it's actually all three angles are congruent, but by knowing two, you know three. Okay, so if we know that two sets of angles are congruent, then the triangles are similar. So we could say triangle, and we can put the first one in any order we want. ABC is similar to triangle, and then match up the corresponding angles, D, E, F. And this would be by angle-angle similarity. Okay, so how are we going to use this? As you can see, we're going to use this on 3 different problems here, and then we'll do some word problems, which are the easiest out of everything that we've done. I saved the easiest for last. Okay, so it says find the value of x. So the first thing I'm going to say to you is, do you see 2 triangles? Hopefully you're saying yes, and you see this big one right here, and then this smaller one right here. What you need to do is you need to draw them separately. So I'm going to draw the big triangle, and then I'll draw the small triangle. Okay. All right, so this is the big triangle, F, G, L, and this is the small triangle, I, K, L. All right, so first off, you should notice that angle G is a right angle and angle K is a right angle, and angle L is the exact same angle, so these 2 triangles are similar. So we can make a proportion to solve for x, but now we just have to make sure that we label the sides correctly. So I'm going to try a color code here. This is FG, this is FG, that's X. All right, this right here, this whole length right here is not 48, it's 4 plus 8. So this side right here is 12. On the small triangle, this is 5, IK is 5, this right here is 8. So now, using the 2 triangles that we drew, we can make a proportion, cross multiply, and solve it. So in between my blank angle and my right angle is x. Start with that. Blank angle and right angle is 5. And then 12, which is in between my right angle and my 1 angle tick mark, and 8. And then you just have to cross multiply. 8x is equal to 60. Divide by 8. X equals 7.5. And that's it. Okay, so when you see 2 triangles, but they're not separate, you have to draw them separate. All right, let's try another one here. Do you see 2 triangles? Let's draw them separate. Okay, so I'll draw this one right here. Look at that. Can I drag it? Oh, how much better is this? Ooh, nice. All right, so this right here is 10, and this right here is 8. Okay, and I know that this angle is this angle right here. Okay, so now what I want you to notice is that these 2 triangles share this angle right here, right? They are in the big triangle and the small triangle, so I know it's congruent to itself. All right, now I'm going to draw the big triangle, which is this one right here. Close enough, right? Like this, and go over here, and look, it even took my marks with it. How wonderful. Well, it took one of them. And it also has this angle right here. Okay, so now I'm going to label what it has, and I know that this side right here is 12. And then this side right here, people want to say 10x, but 10x is not correct. What I want you to think about is that if this was 5, how long would you say that side is? You would say it's 10 plus 5, which is 15, right? Not 10 times 5, which is 50. So when I want to say how long this side is, it's 10 and x more. 10 plus x, 10 and x more. Now I can make my proportion, cross multiply, and solve it. So I'll start with the smaller triangle. I'll do this side right here, which is 10. That's in between my 2 and 1 tick mark, 2 and 1 tick mark, 10 plus x. Then I have this 8 right here in between my 1 tick mark, no tick mark, and 12. 8 over 12. Make sure you don't do 12 over 8. All right, cross multiply. 8 times 10 plus x is equal to 120. 80 plus 8x is equal to 120. Subtract 80 from both sides. 8x is equal to 40. Divide by 8. X is 5. I cannot believe I guessed x is 5 correctly. I should go play the lottery. Okay, I just made up a random number and it happens to be the number I made up. Okay. Last one before I do some word problems here. Do you see the two triangles? I want to draw them separately. Before I do that, I could say right now they share angle L. So that's the angle, like I'm going to mark congruent to itself. So I have this small triangle. First, I'll start by tracing. I should put that right angle in there. All right, on the small triangle, this right here is 7, and this right here is 3. All right, now for the big triangle, I'm going to erase those lines so that they don't come with me. I have the big triangle right here. Oh, it didn't come out as nice. I wanted to, though. There we go. Okay, I'll put in the right angle and the shared angle, and then I will copy it and drag it over here. Look at that, technology. All right, this side right here is 14. This side right here is this and is addition. X and 3, x plus 3. All right, my proportion. All right, so I'll start by picking this 7. I could have picked the 3. I could have started with the 14 or the x plus 3, but the smaller triangles, I drew it up above, so that's what I like to start with. So 7 corresponds with 14, and then 3 with x plus 3. All right, cross multiply. 7 times x plus 3 is equal to 14 times 3, which is 42. Distribute your 7. Subtract 21. Divide by 7. And that's it. X equals 3. Okay, last two. I'm going to tell you right now, the one that we do on the test is more similar to this one. So you want to follow the pattern I'm giving you because it's not as easy when there's fractions involved. People usually can do the ones without fractions in their head, but we want a way to do all of them, and I'm going to give you one with a fraction. Okay, so it says, according to Greg, a perfect cherry pie has a ratio, not a ration, a ratio of 240 cherries to every 3 pies. How many cherries does Greg need to make 9 pies? So I need to know that I am comparing cherries to pies. I'm going to use a proportion to solve this. So I was given that it takes 240 cherries to make 3 pies. I want to know how many cherries, so that's an x right here, do I need to make 9 pies? And then you can cross multiply that. 3x is equal to 2160. Divide by 3. X is equal to 21 divided by 3 is 7. 60 divided by 3 is 20. 720 pies. All right. On a map to Florida, a quarter of an inch represents 10 miles. So I'm comparing inches to miles. I didn't finish reading yet, but I know that that's what I'm doing. A quarter inch, instead of writing a quarter like this, I know 1/4 is equivalent to 0.25. So you can either do a quarter or 0.25. It does not matter to me. I'm going to stick with a quarter because I'm not going to use a calculator. If you want to use a calculator, you can put 0.25. So I'm going to do a quarter over 10 is equal to, it says, if it is approximately 2 inches. Where does inches go? The numerator or denominator? numerator. So I'm going to put 2 here. From Orlando to Ocala on the map, what is the actual distance, x? So I'm going to cross multiply. I have 1/4 x is equal to 20. So I'm going to do it without a calculator. If you wanted to do it with a calculator, you can divide both sides by 0.25. So you can change this to 0.25x equals 20. I'm not going to do it that way. I know that this means times 1 divided by 4. So to get rid of the times 1, I have to divide by 1, which is going to give me the same answer. But to get rid of the divided by 4, I have to multiply by 4. So I'm going to multiply this by 4 and divide it by 1. So I get x equals 80. So 80, and then I look for my unit. It was in my denominator, so 80 miles.